1. Write in brief about general classification of surveys. Answer. In general, surveying can be classified as A. Classification based upon the nature of the field. Based upon the nature of the field, survey can be classified as 1. Land surveying. Land surveying are classified as topographical survey. This survey is used to determine the natural features of a country such as rivers, streams, lakes, woods, hills, etc., and such artificial features as roads, railways, canals, towns and villages. Cadastral survey. This survey is used for the fixing of property lines, the calculation of land area, or the transfer of land property from one owner to another. City survey. This survey is used for the construction of streets, water supply systems, sewers and other works. Point 2. Hydrographic survey. Marine or hydrographic survey deals with large water bodies for purpose of navigation, water supply, harbor works, or for the determination of mean sea level. 3. Astronomical survey. The astronomical survey used for determining the absolute location of any point, or the absolute location and direction of any line on the surface of the Earth, by making observations to the heavenly bodies such as the Sun or any fixed star. B. Classification based upon the purpose of survey. Based upon the purpose, survey can be classified as control surveying, establishing the horizontal and vertical positions of widely spaced control points using principles of geodetic surveying. In Nepal, control survey is done by a department of survey. Engineering survey. This is undertaken for the determination of quantities or to collect sufficient data for the designing of engineering works such as roads and reservoirs, sewage disposal, or water supply. Military survey. This is used for determining points of strategic importance. Mine survey. This carried out for exploration of mineral wealths beneath the surface of the ground, i.e., coal, copper, gold, iron ores, etc. Geological survey. This is used to determine the different strata of rocks of the earth crust. Archaeological survey. This is used for unearthing relics of antiquity. C. Classification based upon the instrument used. Based upon the instrument used, survey can be classified as 1. Chain surveying. Only linear measurements are taken with a chain or tape. It is used when the area is comparatively small, fairly level and open with simple details, no angular measurements to be taken, generally used when high accuracy is not required. 2. Compass surveying. Horizontal angles are measured with a compass in addition to linear measurement with a chain or tape. Point 3. Plane table survey. Both plotting and taking measurements are simultaneous. Point 4. Theodolite survey. 5. Tachyometric survey. 6. Triangulation surveying. 7. Aerial surveying. 8. Photogrammetry. Using photographs, vast areas difficult to reach. 2. What do you mean by paint and varnishes? What is the purpose of using it? Answer. Paints. Paints are liquid coating which are applied on the surfaces of timber, metals and plastered surfaces. After drying, it form very thin film and provide protective, smooth and pleasing appearance on the painted surfaces. Purpose. Functions of using paints. The purpose/functions of the paints are: it provides a smooth and attractive surface. It prevents corrosion in metal structures. It prevents decay of wood-work. It protect the painted surface from weathering effects of the atmosphere and action by other liquids, fumes, and gases. It is used to give a decorative effect on the surface. It prevents the formation of bacteria and fungi, which are unhygienic and give an ugly look to the wall. It check the formation of bacteria and fungus, which are unhygienic and give ugly look to the wall. Varnishes. Varnish is the solution of resins or resinous substances like amber, copal, shellac, gum resin, etc. in solvents like oil, turpentine, alcohol, etc. After application of varnish, solvent evaporates and leaves a hard, protecting, transparent and glossy film on the varnished surface. It is commonly used on wooden surfaces to brighten the grains of wood. Purpose, functions of using varnishes. The purpose/functions of the varnishes are: moisture resistance. Varnish creates a barrier against water, preventing warping or swelling. Chemical resistance. protects surfaces from chemicals, oils, and stains. UV protection. Some varnishes have UV inhibitors to prevent fading or degradation from sunlight. Wear and tear. Adds a durable layer to resist scratches, abrasion, and other physical damage. Improves appearance. Varnishes deepen color and grain of wood, giving it a rich, glossy, or matte finish. Gloss control. Available in different sheens, glossy, satin, or matte, depending on the desired look. Clear coating. Allows the natural beauty of the surface to show through while still offering protection. Seals porous surfaces, such as wood or painted surfaces, helping in smooth finish and long-term durability. Used in art conservation to protect paintings or sculptures from environmental damage. 3. Describe shortly classification of different bricks. Answer. There are two main types of bricks. Unburnt bricks. These bricks are dried through sunlight. It is also called sun-dried bricks. They have very low strength as compared to other types of bricks. Burnt bricks. They are further classified into the following categories. First-class bricks. The earth from which bricks have been made should be suitably proportioned. It should be free from small pebbles, lime lumps, organic matter, and sodium salts. Following are characteristics of first-class brick. Size of the burnt brick should equal to standard specified size. It should be well burnt. Its color should be uniform yellow, or red. It should not absorb water more than 20% of its own dry weight when kept in water for 24 hours. It should have a firm, compact, and uniform texture. Its surface should be regular and sides parallel. Edges should be sharp and at right angles to each other. Its crushing strength should not be less than 105 kg/cm. 2.2 First-class bricks when struck with each other give a sharp metallic ringing sound. It should not show any signs of efflorescence when bricks are dried after soaking in water. Use. Excellent for all types of construction in the exterior walls, flooring, face work where plastering is not done, RCC work, etc. 2. Second-class bricks. Brick of this category should possess the following properties. The brick of this class should also be well burnt. They can even slightly be overburnt. Minimum crushing strength should be 70 kg/cm. 2. They should not absorb water more than 22% of its own dry weight when kept in water for 24 hours. 2. Second-class bricks when struck with each other give a metallic ringing sound. These bricks should not show appreciable signs of efflorescence when soaked. Bricks are dried. The shape, size and color of the brick are slightly distorted. Slight distortion and surface cracks may however be allowed. Uses. It is used in unimportant situations or at places where the masonry is to be plastered, RCC work, and in lime concrete, etc. 3. Third-class bricks. A third-class brick should possess the following properties. These bricks are generally underburnt. They are soft and light-colored. They may suffer from intensive efflorescence. They emit a dull sound when struck against each other. It should not absorb water more than 25% of its own dry weight when kept in water for 24 hours. Uses. It is used in temporary constructions not subjected to heavy loads or heavy rains, used mostly in the ordinary type of construction and in dry situations. 4. Differentiate between shear force and bending moment. Calculate the maximum bending moment of simply supported beam of span L, having uniformly distributed load W per unit length. Five. Define leveling. Explain the temporary adjustment of leveling. Answer. The method of surveying which is used for determining the relative height or elevation of points or objects on the surface of the earth or beneath the surface of the earth is called leveling. It deals with the measurements in vertical plane. The main objective of leveling is to measure or verify the height of specified points with respect to a datum. Temporary adjustment of level. The adjustment which are carried out at each setup of level before taking any observations is known as temporary adjustment of level. The temporary adjustment of level consists of setting up the level. In this operation, first the tripod stand is set up at a convenient height having its head horizontal. Then the instrument is taken out from box by holding it in right hand and fixes it on the top of tripod by rotating the lower part of the instrument with right hand and holding firmly the upper part with left hand. Before fixing, the leveling screws are required to be brought in between the trib ratch and trivet. The bullseye bubble, circular bubble, if present, is then brought to the center by adjusting the tripod legs, leveling up. Next step is leveling of the instrument. Leveling of the instrument is done to make the vertical axis of the instrument truly vertical. Accurate leveling is done with the help of foot screws as described in the following steps. Step 1. Loosen all the foot screws. Rotate the upper part of the instrument and bring the level tube parallel to line joining any two of the foot screws such as screws A and B. Step 2. Bring the bubble to the center of the level tube by rotating both the foot screws either inward or outward. The bubble moves in the same direction as the left thumb. Figure A. Step 3. Now the level tube is placed over the third foot screw again by rotating the upper part of the instrument through 90 degrees such that level tube is perpendicular to initial line. Step 4. Then the bubble is again made in the center of the level tube by rotating the third foot screw either inward or outward. Figure B. Step 5. To check the central position of bubble, again turn the instrument so that the level tube is parallel to initial position, i.e., parallel with line joined by foot screws A and B. The bubble will remain in the center if the instrument is in permanent adjustment. If bubble knot remains in its central positions, then check for permanent adjustment. Point 3. Elimination of parallax. When the image formed by objective lens does not lies in the plane of crosshairs, then there will be a shift in position of image due to moving of eye. This shifting of image is termed as parallax. Parallax is removed by focusing eyepiece and objective in following two ways. Focusing the eyepiece. Focusing of eyepiece is done to make crosshairs sharp and distinct. For this, the telescope is first pointed towards the sky. Then the ring of eyepiece is turned either in or out until the crosshairs are seen sharp and distinct. Focusing of eyepiece depends on the vision of observer, and thus required whenever there is a change in observer. Focusing the objective. Focusing of objective lens is done in order to see clear image. For this, the telescope is first pointed towards the object. Then, the focusing screw is turned until the image of the object appears clear and sharp, and there is no relative movement between the image and the crosshairs. This is required to be done before taking any observation. 6. Differentiate between on-way slab and two-way slab. What are the design procedure of slab? Seven. What happens if soil is not compacted? How does compaction affect the engineering properties of soil? Answer. Compaction is the process of increasing the density of soil by reducing the volume of air between soil particles through mechanical means like rolling, tamping, or vibrating. It does not involve adding or removing water or changing the soil's composition, it simply packs the particles closer together. If soil is not compacted well, if soil is not properly compacted, several issues can arise, especially in construction and engineering. Settlement of structures, buildings, roads, or pavements may sink unevenly, leading to structural damage or failure. Poor load-bearing capacity. The soil may not be able to support heavy loads, increasing the risk of foundation failure. Water seepage and erosion. Loose soil allows water to seep in easily, leading to erosion and weakening of slopes or embankments. Increased permeability. Water can move through the soil faster, possibly affecting nearby structures or causing instability in slopes. Frost heave. In cold climates, moisture in loosely compacted soil can freeze and expand, causing movement or damage. Compaction affects engineering properties of soil in many ways. Increase in dry density. Compaction reduces the air voids between soil particles, increasing the dry density. Higher dry density generally means the soil is stronger and more stable, which is ideal for supporting structures. Improvement in shear strength. Compacted soil has better interlocking and friction between particles. This enhances the soil's shear strength, making it more resistant to sliding or failure under load, especially in slopes or foundations. Reduction in compressibility and settlement. Well-compacted soil undergoes less compression when subjected to load. It minimizes settlement of structures like buildings or roads, helping maintain level surfaces and structural integrity over time. Decrease in permeability. By reducing void spaces, compaction makes it harder for water to flow through the soil. Lower permeability helps control seepage and groundwater flow, which is crucial for earth dams, embankments, and foundations. Increase in bearing capacity. Compacted soil can support greater loads without failure. Why it matters: it is essential for foundation design, where the soil must safely bear the weight of structures. Reduction in frost heave. Compacted soil holds less water, which reduces expansion due to freezing. This is important in cold regions, where frost heave can damage pavements and foundations. Improvement in soil stability. More compacted soils are less prone to erosion or landslides. Improves safety and durability in slopes, embankments, and retaining structures. (8) What is the difference between pipe flow and open channel flow? Discuss in details with examples. Answer: the difference between pipe flow and open channel flow are: definition. Pipe flow. Pipe flow occurs when a fluid flows completely enclosed within a conduit, usually circular in cross-section, such as a pipe. The flow is under pressure, and the pressure difference drives the movement of the fluid. Open channel flow. Open channel flow occurs when a fluid flows with a free surface exposed to the atmosphere, such as in rivers, canals, or partially full pipes. The flow is driven primarily by gravity rather than pressure. Point 2. Driving force. Pipe flow, driven by pressure differences, pumping systems, or gravity-induced pressure. Head. Open channel flow, driven by gravity along a slope and the channel's geometry. Point 3. Surface exposure. Pipe flow, no free surface, the fluid fills the entire cross-section. Open channel flow has a free surface, only part of the conduit is filled. (4) Flow regimes. Pipe flow, laminar or turbulent, based on Reynolds number. Governed by Darcy-Weisbach or Hazen-Williams equations for head loss. Open channel flow, classified as subcritical, critical, or supercritical based on Froude number. Governed by Manning's equation, Chayes equation, and continuity and momentum equations. Point 5. Cross-section shape. Pipe flow, typically circular. Open channel flow can be rectangular, trapezoidal, triangular, or irregular, natural streams. Point 6. Measurement of flow. Pipe flow, measured using devices like Venturi meters, orifice meters, flow nozzles, or electromagnetic flow meters. Open channel flow, measured using weirs, flumes, float methods, or acoustic Doppler current profilers, ADCPs. 7 Examples. Pipe flow examples: water supply through city pipelines, oil or gas transport through pipelines, cooling water in closed-loop systems, flow in a pressurized irrigation system. Open channel flow examples: river and stream flows, water in irrigation canals, wastewater and sewer lines when not pressurized, rainwater flowing in roadside drains.